ladies and gentlemen.
So let's talk writing linear equations and expressions. So when we deal with word problems, every problem is different. So we have to keep in mind that our variables are going to change and the structure is going to be different every time we do this. But we do have a few things that can help us out. Typically, if a number is designated with change of some kind, like 50 miles per hour or anything like that, that's typically a coefficient to a variable. Otherwise, we need to make sure that our equations, if we have an equation, is written so we have the same unit on the left-hand side and the right-hand side. So money equals money, or miles equals miles, feet equals feet, people equals people. You get the idea. So let's dive in. So question 1 has us on Tuesday night. Sam sold X hot dogs each hour and for 3 hours, and Pat sold Y hot dogs each hour for 2 hours. We're going to write an expression, so no equal sign, representing the total number of hot dogs sold by Sam and Pat on Tuesday night. So we have some numbers and we have some variables in the representation. So X is hot dogs, Y is hot dogs, and 3 is hours of selling hot dogs. 2 is hours of selling hot dogs. And then we're adding all of these hot dogs together. So, simply put, this one's not that bad. For Sam, we have 3 hours of selling X hot dogs per hour, plus we have 2 hours of selling Y hot dogs per hour. And that's our expression. We have Sam here and we have Pat here, and we're good. Not too hard there. This one, now we're going to deal with an actual equation. Sarah's car holds 15 gallons of gas at the start of a trip. At 60 miles per hour, the car's gas mileage is 22 miles per gallon. We're going to write an equation G that models the amount of gas in Sarah's gas tank after T hours on the trip. So we want an equation, a function even, G of T, where the equation should be in the unit of gas, the amount of gas. And we have quite a few numbers and quite a few units. So we got to make sure that when we're finished, we have something that will be in the unit of the amount of gas. So 60 miles per hour, 22 miles per gallon, and 15 gallons of gas. So we're starting with 15 and we're taking something away, right? We have 15 gallons of gas in our gas tank and we're depleting gas. It doesn't make sense that we'll have more gas at the end of the trip than we had at the beginning if we're not refilling, right? So 15 done, we've used it. Now we have 60 miles per hour, 22 miles per gallon, and T hours on the trip. So where's gas come in? We have 22 miles per 1 gallon of gas. Well, that means if I want gas to be the unit I'm using, I need it to be in the numerator. So I'm going to try to figure out how I'm going to settle these numbers up on this side over here. So I need gallons of gas to be in the numerator. So 1 gallon of gas is equal to 22 miles. Now, in order to cancel out the miles, I need to multiply it by something that has miles in the numerator. So what has miles in the numerator? That would be our 60 miles per hour. So we have 60 miles for 1 hour. And if I multiply these, that means the miles cancels out. So I have 1 times 60 over 22 times 1, and I have gallons per hour. Great, but I just need gallons. What's the last thing we got here? We have T hours. So if I multiply this by T, which is in hours, hours cancels out with hours, and that just leaves us with gallons. So this would be minus 60 20 seconds times T. And this is in the units of gallons of gas. This is in the unit of gallons of gas. And we want an equation in the unit of gallons of gas. So we're done. If you would like to clean it up a little bit, 60 divided by 22 is reducible. We can always write it g of t is equal to 15 minus 30/11ths t. There you go. So keep in mind, the units are really, really important, and we might have to manipulate the numbers we're given so that we have the units we want at the end. The last one, not as bad, I promise. We have Teresa planning a vacation, and they will be renting a car. The car costs $35.95 per day plus tax. There's also a one-time untaxed fee of $3.95 to rent the car. Tax is 8.5%. We need an expression to represent the cost of Teresa's car rental in dollars, representing for renting for K days. So there's two ways of thought for this, and I want to show both to you. The first one would be we have the untaxed fee, which is the 3.95, and we're renting for $35.95 per day. So that would be, what was days? K days times K. And then we're taxing that by 8%. So we're going to add an 8%. So 0.8 of the $35.95. $35.95 K. This is one expression. We have the one-time untaxed fee, we have the cost per day, and then we have the tax on the cost per day. That's one expression. Another expression would be to combine the taxed part with the time per day part. And if you think of it, this is 8%, this is 100%. So if I combine these two, I could also just have, we are adding 108% of the $35.95K. That's an awful looking K, but you get the idea. And that is another expression. So both of those expressions represent the cost for Teresa. That is it for us. If you have any questions, let me know. Otherwise, I'll see you in the next video.